everyone. Thank you for joining the 7th edition of Keysight Connect. Today we're going to be talking about malicious documents, and we're going to go through some examples of how they work and how we can analyze them. First, before that, I'm going to share some information about Keysight Technologies, a couple of words. So, Keysight's history is actually goes way back all the way to 1939, when Bill Hewlett and David Packard started the company HP. And initially it was founded as an electronic management company. Way further down the line, Agilent as a company was spun off from HP and retained the electronic management business. And then shortly after, in 2014, Keysight again split from Agilent and retained this electronic management business. Basically, Keysight's history goes back way back over 80 years of a technology company delivering solutions for enterprises, service providers, governments all around the world, with top-notch products, with business from anything from prototype validation to manufacturing, optimization of the products once we deliver them to the customer, and going to world-changing innovation through latest technology. So at Keysight, there's a lot of technologies that are worked on even before it gets into consumer area or public area. Like example would be the 5G industry. And Keysight's let's say business operates in many fields such as automotive, aerospace and defense, wireless, networking and cloud, IoT, and through all these, we aim to bring world-class products and also secure products. So, for example, for automotive, we have teams that are focused on that area, on securing software that runs in this area, and so on. To that area, Keysight's engineers, even such as myself and other of my colleagues, work with various technologies, from classics like C, C++, or Python, to Kubernetes, microservices, the containers, and everything, in order to deliver these products. And the way we do it, again, by offering a wide variety of latest technologies, and it's Keysight's goal to help employees grow and sometimes embrace autonomy. So that might sound somewhat generic or anything, but it is something that it actually is something that actually people work for. So finding meaning in your work and working on products, on solutions that are valuable, and to work for things that change the future. And to that end, I mean, I can provide examples. For example, my team, we've worked on a security product from the ground up here in Bucharest, and it's something that's not so often found in places. And success is about people, and here there's this bullet here that says visionary engineers who achieve breakthrough contributions. And I really like this bullet here, because it is it is meaningful and applied to our team, at least. So we have I have colleagues that have in the security area that have this disclosed, found new vulnerabilities. They have CVEs under their belt. We have colleagues that have have had their research published at international conferences. We have a colleague that's going to present this year at DEF CON, for example. It's a lot of this part of research and finding and developing new solutions is really it really matters here. So if you want to work for what is probably the best company in the world, pun intended, please take a look at jobs.keysight.com at our job openings portal, or just drop an email, and hopefully we can be part of our team. So going back to the to our order of business about the malicious documents. What we're going to talk about is really quick intro on malicious documents and how we why is this topic, let's say, important, and then we're going to go through some examples like Emotet, a document tied to Emotet, and the one tied to AgentTesla. I'm going to discuss some other techniques that are present in this area for malicious documents. So why are malicious documents important? Well, pretty much any business, if you think of it, from a small business or towards any enterprise, works with emails, works with documents, you get invoices, you communicate with clients and so on, contractors and so on. So this pretty much sets an attack surface for someone that wants to use this technique with malicious documents. Pretty much an incredible attack surface. Basically, any business in the world can potentially be a target. And usually, when this happens, there are kind of two ways: either large volume spam, spray and pray, or people try to use some reconnaissance at first, try to figure out to do some more targeted, let's say, messages. But they all have some things in common. Basically, they have an attachment, which is usually a document or a zip file or something like that, or some URLs where you can download these payloads. So this is a very effective way of delivering malware infecting systems. And it uses a combination of obfuscation and social engineering. So obfuscation, because these documents are specially crafted, so they once you open them, there's more than meets the eye. So there's more things under the hood that code that gets executed. At the same time, there's a social engineering component, because they are let's say they're creating this false sense of urgency to convince you to open these documents, to click in there, enable anything by issuing by statements like, I don't know, this email says, okay, we're going to cut off your internet, or you have unpaid bills, we're going to cut off your services, and so on. And virtually or other techniques the other way around, with incentives. Hey, look, you're going to get a big corporate bonuses are out this year, and they're going to be huge. Click here and open this document to see what you're going to receive. So looking at these documents, what they do inside, most of the time we're going to have to deal with macros, which are basically a piece of embedded code, usually written in Visual Basic. We have a small example here, which basically just pops a command prompt and prints out some strings. Usually, or initially, these macros were used and are still used for legitimate purposes as well. So you can use them for automation. You can use them to in Excel, for example, to use for formulas and whatnot. But at the same time, you can use them for malicious purposes. So you could run a PowerShell and download the file, execute it, and so on. So this is pretty much the infection vector, let's say, that we talked about. You have an email with an attachment or a URL link to download the document. It then prompts you to enable macros. So then the code gets executed, downloads additional payloads, executes the malware, and so on. You're basically infected at that point. We have some examples of emails that were sent to us. For example, hey, your package has been delivered to your neighbor. Track your package. Or this one here. Here you have your invoice is here. Please open up to check what's going on. But these aren't, let's say, Office in this case, but at the same time, it might as well be a document there. And I was saying that these documents will prompt you to enable the content. Most of the time, you'll see some headers just like this one, or like DocuSign. This is the example of a DocuSign template. Basically, when you open these documents, you will actually not see any sort of content in them. You only see these templates or that say, okay, you cannot see this document. This document is encrypted. It contains some external content or whatever. You have to click on enable editing and enable content. That's because a couple of years back, Microsoft changed the default setting for these macros. So basically, by default now, they are not enabled on in Word, Excel, and so on for externally received documents. So that's why they're going to try to prey and prompt you to enable the macros in order to get that execution. So really quick now, in order to stay safe, you have pay attention to your emails. That's a really big part of it. Any documents that you receive and have these requests, to enable content, that's a pretty big red flag. And usually, it's really good to use. If you receive this on your corporate or your enterprise account, request help from IT security. Report this as phishing. These will or submit them to your internal security solutions in order to analyze these documents before actually opening them and enabling content if that's requested. At the same time, if you receive this sort of the documents at home or on your private computers at home, there's a variety of tools out there that are public tools, free to use, like VirusTotal. There's Cuckoo Sandbox. Instances that are public. I think there's one actually posted by the Estonian CERT. There's others in Luxembourg, I think. Not sure how many, or if there are any public sandbox instances in Romania, but there are tools out there that allow you to submit these files and scan them before opening them. Going further with Emotet, Emotet was actually taken down at the beginning of this year, but I chose to take a look at one of these documents because it's still the way they worked is still relevant. It's not just them. They weren't the only ones using these techniques. What was interesting about them is that they used a lot of different templates. They would update these templates regularly, different types of code obfuscation or methods of downloading the payloads, updates in the command and control traffic, so they would not get detected by various security devices. And most of the time, they were distributed as via spam as documents, obviously. I think there was an article at some point that said once after the Emotet was taken down, I think there was I hope I'm not wrong here, there was a drop of almost 10% in the world spam distribution. That's that's pretty big. At the same time, having Emotet being disabled, that's not something, problems are solved. We don't have to fear this sort of stuff, this sort of techniques anymore, because it's where one, threat actor gets taken down, others will come up to fill that gap. And here we have some examples of some templates and some documents that were used by Emotet in order to convince users to enable that content and enable them to run their code. So again, enabling editing and content is really, really risky thing when dealing with documents from suspicious emails. So in order to start this analysis, there's actually more ways that more than one way to analyze document or a file, a malicious file, suspicious file, say. So we can either go to static analysis, which is what we've chosen here, mainly because it allows us to analyze the file without actually opening it or running anything inside it, and you can also, as I said, submit it to a sandbox and monitor its behavior. Quick, run of strings on document will show us some, apart from all the other content, will show us a big blob of data with this string, close bracket ANW, open bracket 3. That keeps repeating itself. And we're going to see why this is interesting later on. Aside from that, I use a tool called OliDump, which is a program to analyze documents. It was written by Didier Stevens. He actually wrote a lot of tools for analyzing documents, PDFs, and so on. They're really useful. Here we can see the actual structure of the document. And what's interesting to see here is that we actually see that there's 3 macros in this file, aside from the actual document itself, content of the document. And we can actually use OliDump to take a look at what these macros contain. So the first one basically has a bunch of attributes. And what's really interesting here is that it has a private sub document open, which runs basically this function here. Now, document open and auto open are basically special methods that are run without any sort of user interaction when the document is opened. Now, again, they need that permission to enable the content. But once you enable that content, this will get whatever's running here is basically executed without any sort of other human interaction. And aside from document open, auto open, there's other methods that are used by malicious threat actors. There's document close. Basically, you open the document, you look inside, there's nothing interesting. You enable the content, nothing happens. At some point, they're going to close the document, but when you trigger that close, that's when all the bad stuff is going to happen. What we actually see in the 10th stream here in the macro here is actually a really large piece of Visual Basic code. So it's also almost like 300 lines of code. And I've highlighted here what basically, based on our analysis, is a lot of, let's say, red herrings. These are a lot of variables that are instanced. They create files. They write some gibberish in it that ultimately don't have any, let's say, value. They don't want to actually do anything. They're just here to make analysis more difficult and waste your time, let's say. I actually think I have a code here. So in the end, out of all these 300 lines that are here, again, most of this is really not useful. What's another interesting item here is that you use on error resume next. So this is actually used in order to be able to run and write, wrong instructions, wrong pieces of code that will be ignored and will not stop the execution of the code. And in the end, once we remove all that, let's say, waste of code, and also if you remember the ANW3, if we replace that with we just remove all those occurrences, we'll be left out with some, say, much more manageable piece of code to analyze. So here we see a variable called SF4, which basically concatenates some, let's say, some other variables, some strings. These are actually not declared. There's nothing in them. But what's interesting here is is story ranges .items. So basically, stories are a way to iterate over pieces of content in a document. So, for example, a header is a story. The content of the document is another story, and so on. So you can use this in order to select a piece of the document that you want to use. Then we have these variables here that ultimately type process, Win32, Win management, and application.name, which is basically Microsoft Office, and it selects a 6 characters, so that's S. So ultimately we get Win management S, semicolon, Win32 process. So that gives us an idea what's going to happen next. I've actually renamed one of the methods of the functions there to function replace, because in the end, that's what it actually does. Does replace of all these characters, the ANW character that I mentioned earlier, with nothing. And it is used to load up the content from the document and remove all these instances. So that content that's used from stories is basically that big blob of data that we saw earlier when we ran strings. And what's going to happen is basically it replaces all these strings, and it's going to run a process. It's going to execute the code in there. And if we decode that piece of data, we're going to see that's basically going to launch command. It's going to pop up a message box saying word experience, and they're trying to open the file, and then it's going to behind the scenes going to run PowerShell with this payload, which is base64 encoded. Again, decoding that payload, we can see another piece of code, and which is again obfuscated. You can see here, for example, it's using type 1032 is basically saying system IO directory. Here I think it's system net service. What was it? Forgot about it, which one this was. But again, silently continue with on errors. And further down the line, it's going to concatenate a lot of these strings here. Again, ANW3, if you remember, and what happens in the end is basically creates an array of URLs, and for each of these URLs, it's going to run. It's going to download the content there and going to run the files. So at this point, we're pretty much we pretty much know what the intentions of these documents are. So this is about, let's say, the Emotet analysis and what we could extract using, let's say, publicly available tools for static analysis. Um, Another, let's say, example that I want to talk about is AgentTesla. AgentTesla is started out as an info stealer. It works on a pay-per-use model. It's been active since 2014. It's pretty much around the same time that Emotet was started out. So all this kind of sounds really similar because a lot of these threat actors use, let's say, similar behaviors, pay-per-use, distributed via spam, and then free targets. So here I have, there was a graph of how many instances of AgentTesla were found during the course of 1 month between January and February on a platform called Malware Bazaar, which might not sound a lot, like 60, 80, 100 samples a day, but this is only from a couple of researchers that submit their findings there. Interesting also, AgentTesla was targeting was present here as well. So there were last year there were some sorry, so some attacks with spam emails, from disguised as from banks, from DHL, from the postal service, so on. And for the most part, for the examples that I found, most of them were using at the time CV 2017 118082, which is an arbitrary code execution, which allows arbitrary code execution in Microsoft Office using an exploit in vulnerability in equation editor. This actually has been patched, so in the latest versions of Office, they're no longer usable. But at the same time, it's interesting to see that this exploit list is still widely used, and not just by AgentTesla. Keysight uses this, Forum Book uses this, and there's many other. What's interesting about this one here is basically it's not using any macros. It's just a different form of let's say a different form of a document, which is based on a vulnerability in the product itself. Again, using some public tools from Didier Stevens, RTF. It's actually not from Didier Stevens. It's actually from another project called Décollage, I think. It's a Belgian group. You can. It's called RTF OBJ, RTF object. This actually detects, the fact that it's an exploit for the equation editor. So it's really brings out a red flag here. But in order to see what's going on, by dumping let's say the binary part of the shell code, let's say, you can actually go ahead and then in the end use shellcode debugger and emulate the actual behavior of the exploit. And we can see that it's loading library, URLmon, it's downloading a file, and then it's going to run it. So that's pretty obvious malicious behavior here. And just a quick, the reason I like to use these tools now is the fact that they allow for really, really quick, analysis of these files. You can go and you can chain these and automate these tools if you want to go for large amounts of samples for analysis. And instead of going for detonating them in a sandbox, which might take up at least a couple of minutes per file, you can pretty much do hundreds of files or thousands of files per minute with this approach. So we mentioned, the macros and the equation editor exploit, but these are not the only ones that are used out there. There's other techniques, and some of the more let's say notable that we've seen are password protected documents in the Excel files. This is a really interesting thing. The Excel files have not just Excel files have the possibility. You have the possibility to encrypt your content. You can password protect the files. But there is a special password in the code of Excel, if I'm not mistaken, that you can use. And this is Velvet Sweatshop. So basically, you can use this password to protect the content of the document. But when you open that document, it will not require you to enter that password if you're using this particular string. Other options other techniques that we've seen are the usage of Excel cells and formulas, Excel and macros. We've seen these in Trickbot as well. There's other things like hidden sheets and the very hidden sheets. Now, hidden sheets can be in Excel can be let's say revealed from from the Excel options. However, the very hidden sheets cannot be revealed with human interaction, like going through options in Excel. You need to a special, let's say, there's a special. You have to find some strings that are relevant, are basically define the hidden sheets, and those have to be changed in order to be able to analyze those, to see those. Well, I mentioned the Velvet Sweatshop. So basically, if you look at an Excel file that is password protected using Velvet Sweatshop, you'll see that you have this stream called encrypted package, and by using the Velvet Sweatshop password, you can actually see then that the actual content in there. And basically, once you open that up, you can easily go for the same approach, dump the binary, the payload, and look for shellcode and use shellcode debugger for that. So here we have another example with sheets in I think this is a Trickbot Excel file, and we can see some interesting things here. So it's a DocuSign. So it's probably going to show up another DocuSign protected. You need to enable content, so on, and then it's going to use formulas embedded in cells in order to achieve that is a payload download and execution. I think I actually have an example here with so this was basically this is something I pulled out from a Trickbot document. So again, auto open in order to achieve execution without human interaction once able to cut the content. We see some references to some DLLs and then some URLs. So we can pretty much assume that it's going to try to download the content here and run it. And then we see some formulas with references to other cells, and again, those basically have URL download, call URL, and so on. And in the end, on the third sheet, you actually have a formula that basically calls URL download. Show that here. So basically, it's downloading these files as DLLs, and then it's going to execute them. These are, I guess, less. I mean, at least for me, these are less. I don't like these a lot because you have to go through a lot of these cells and follow up with all these variables. But that's just me, I guess. In the end, it's a matter of going through these through the code and following the execution. Say. Again, RAM costs. It's a remote Tax Trojan. Again, using the encrypted package and the valid sweatshop password. Lastly, again, one of the best ways to protect yourselves from this sort of attacks is really to pay attention to the documents that you open, to your emails. Big red flag for the enabled content, for the request for enabling content. And if you're in an environment, in a corporate environment, use the tools, the support that you have from IT, from the IT security. Or if you're at home, use public tools like VirusTotal, Sandbox. Or if you're in the mood to do some analysis of your own, there's some links here for the tools that I've used here. I guess that's kind of it from me. If there's any questions, comments?
Thank you for the presentation. I have simple question that are these kind of attacks only putting people that use Microsoft Windows at risk, or are there maybe variants that can also affect, for example, Ubuntu systems that work in a similar way?
I would actually haven't tested it out. I'm not 100% sure. I would guess that there are two ways to do this in other, say, environments as well. But usually these, let's say, attacks target, Microsoft Word, Excel, Microsoft Office tools, because these are usually used in enterprise environments. In the end, let's say, a lot of these attacks are targeting, they work just like any other business. They want to make money. So what they'll do is try to infect or attack enterprises or targets that have money. So if they're going to infect your system at home, there is value there, obviously, because they can get, they can use their information stealing capabilities, try to get the user passwords, information from your environment, and reuse those, sell those, and so on. But usually, it's going to be targeting corporate environments, and Trickbot, for example, is a great example here. After infecting systems, and doing whatever other information stealing, using their information stealing capabilities, at some point, they'll just drop. They drop, for example, a ransomware, and extort companies for their data back, let's say. And this is something that's been happening more and more often the past year. Well, I guess there's no other questions. Thank you for taking the time to attend this presentation. I hope it was useful and educating. And stay safe.